We got some basic probability today, simple probability. So we're going to understand and apply simple probability to various independent events. So probability P is always equal to the number of desired outcomes out of the total number of outcomes. And don't forget, probability is always between 0 and 1. It's a decimal or a percent. Okay? 0 means there's no chance it's going to happen. 1 means 100% chance it's going to happen. Okay? A fair coin is tossed. What's the probability of it landing on heads? So we're just going to say probability of heads. And you're like, boom, 1/2. Thanks, math. I know you guys know how to do that, right? A fair die is rolled. What is the probability of getting a number greater than 4? So our sample space on a fair die is 1, 2, 3, 4, 5, 6. There's 6 sides. They each have a number on it. So I want to know what's the probability of getting greater than a 4. So there are 2 numbers greater than a 4. That'd be 2 6, which is 1/3. All right, how about this little guy? We roll 2 dice. So you guys, you need to draw the chart. We got to fill it all in. Oh, now we can actually answer these questions. What's the probability of rolling a 7? So the probability of getting a 7. This is always out of 36. Okay, there's 6 times 6 combinations here. So probability of rolling a 7 is 1, 2, 3, 4, 5, 6. There are 6 sevens there out of 36, which reduces to 1/6. All right, then we have the probability of rolling a number greater than 8. We can write that like this. That would mean a 9 or a 10 or an 11 or a 12. So we have commas. What's the probability of getting any of those? So I'm going to count all these up. A 9, a 10, 11, or a 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of getting a number greater than 8, 10 out of 36, because there are 10 numbers right here greater than 8, which reduces to 5/18. All right, then we have the probability of rolling a number less than 2. That never happens if you're rolling 2 dice. So that probability is 0 out of 36, or just 0. Okay. All right. Independent events. So this is events that have no effect on the outcome of the other one. So the best way of talking about independent events is with a deck of cards. In order for them to be independent, what do you have to do between the draws? You have to replace the card. So if you replace the card, the first draw does not affect the second draw because you still have it out of 52 cards, right? But if I take a card out and then I don't replace it for the second draw, now my second probability is only out of how many cards? 51. So that would not be independent, all right? That's the difference. So a fair coin is tossed 3 times. Those are independent events. Like every time you toss a coin, the first one doesn't affect the second one. So what's the probability it comes up heads every time? So this would represent the first toss right here. And you get either a heads or a tails. And then we're going to do a second toss. No. And you get either a heads or a tails. Or a heads or a tails. And then you got to go again. Third toss. Heads or tails. Heads or tails. No? You do not have to do this every time. I'm just showing you all the paths, right? So what could happen? I could get a heads, and a heads. Heads, heads, heads. I could get a heads, a tails. Wait, no, let's go heads, heads, tails. All right? And then I could go heads, tails, heads. Then I could go heads, tails, tails. Then I could start with the tails and go heads, heads. And then I could start with the tails and go heads, tails. Beep, beep, beep.
So it's like third grade.
Yeah. All right, so how many different outcomes do I have here? 8. So what's the probability of getting a heads all 3 times? Heads, comma, heads, comma, heads. There is 1 way out of 8. Yeah. Another way to do this is 1/2 times 1/2 times 1/2. All right. Just gotta I know. Ow. Alright, here we go. A jar contains 3 red marbles and 2 blue marbles. A marble is drawn randomly from the jar. What's the probability that both marbles are blue if the marble is replaced after the first draw? So we're looking for the probability of getting a blue and a blue. So we've got 3 reds and 2 blues. And again, this part A, we're replacing it. So what's the probability of drawing a blue right here? It's 2 out of 5 total. And if we replace it, now I want to get a blue again, then it's still 2 out of 5. So I get 4 out of 25 for the probability of getting a blue and a blue. Now what's the probability of getting a blue and a blue if we don't replace it in between? So the first draw is still 2/5, but now we assume that we got a blue. So now how many blues are left? 1 out of how many marbles that are left? 4. Now there's only 4 marbles. Cross cancel right here, and we get 1/10. All right, we got a whiteboard problem for you guys.